Hi guys, welcome to lesson 8.7, factoring special cases. Our objectives for today are that I can factor perfect square trinomials and the difference of two squares. Our essential understanding states that you can factor some trinomials by reversing the rules that you learned from multiplying special cases of binomials in lesson 8.4. So, problems 1 and 2. Perfect square trinomials. Our rule was that a squared plus 2ab plus b squared is going to be equal to a plus b times a plus b, or just a plus b squared, quantity squared. What we're looking for here, this is that perfect square squaring of a binomial rule that we learned the other day. What you need to look for are the first and last terms perfect squares, and is the middle term twice the product of a factor from each the first term and the last term. So let's just start working through problems and seeing what we see. Letter A, x squared plus 6x plus 9. Are x squared and 9 perfect squares? Yes, they are. X times x, 3 times 3. All right, now, if our factor there is x and our factor there is 3, is the middle term, 6, twice the product of one factor from the first term and one factor from the last term? Well, it would be 2 times x times 3. 2 times 3 is 6, times x is 6x. That's what we have. So we have x plus 3 times x plus 3, or you could write this as x plus 3, the quantity squared. When we get to chapter 11, I would recommend writing it in this format, just because it'll be easier to see what cancels out and what doesn't. But if you write it in this, we can deal with that too. All right. So next up, letter B. We have x squared minus 14x plus 49. Is x squared a perfect square? Yes, it is. Is 49 a perfect square? Yes, it is. So we have an x and a 7. Those are our two square roots there. And is our middle term twice the product of them? Well, 7x times 2 is 14. Oh, so maybe we have a negative sign here because we have a negative b. We have a positive final term. So we've got x minus 7 times x minus 7. Okay. Next up, we have n squared minus 4n plus 4. So again, we've got a positive c term and negative b term, so it means these have to be negatives, and this one is positive. So our factors, we've got an n there, we've got a negative 2 there, so our factors are going to be n minus 2 times n minus 2. Okay. I want you guys to try D, E, and F on your own, and then I will go over it. So letter D, we've got our first term, 16x squared, or 16c squared. Now that would just be 4c. 81, that's going to be 9. Our middle term is negative, so it's going to be a negative 9, right? Negative 9 times negative 9 is a positive, sorry, blocked it, positive 81. So your factors are going to be 4c minus 9, 4c minus 9. Okay? And as with everything that we've done this half of the unit, you can always distribute and use FOIL and make sure you've got the right values. Okay. Letter E, we have 9x squared plus 24x plus 16. Well, 16 is a perfect square. That's just 4 times 4. 9x squared, that's a perfect square. That's just 3x. So our factors are 3x plus 4, 3x plus 4. Oh, I forgot to double check. 3x times 4 is 12x, times 2 is 24x. Okay. So next up we have, you are building a square patio. The area of the patio is 49x squared minus 42x plus 9. What is the length of one side of the patio? So we have a perfect square there. That would be 7x. Perfect square there, 9. This is negative, so that has to be negative 9. So our terms are 7x minus 9. 7x minus 9. So the side length of one side of the patio, since it's a square, is just, sorry, did I just do that? 3 3 3. So square root of 9 is 3, by the way, not 9. All right. Going on, problems number 3 and 4, factoring a difference of two squares. So our key concept on this rule is as follows. For all real numbers a and b, where a squared minus b squared, they are going to equal a plus b and a minus b. So our first, or what to look for is, do we have two terms that are perfect squares? And is one term being subtracted from the other? We have two perfect squares, x squared and 10. Is one being subtracted from 100? Is one being subtracted from the other? Yes. So we're going to have x plus 10, x minus 10. And if you want to double check it and we FOIL it, x times x is x squared minus 10x plus 10x minus 100. X squared minus 100. All right, there's our check. Next up, u squared and 16. Are those both perfect squares? Yes. This is u, this is 4. Are we subtracting one from the other? Yes. So it is u minus 4, u plus 4. Mr. Boland, does it matter if it's plus or minus first? No, it really doesn't. And it's just whichever way you prefer. Okay? All right. You guys try letter C and D, and then I will go over it. So letter C says 9n squared minus 25. Is 9 a perfect square? Yes. Is n a perfect square? N squared perfect square? Yes. Is 25 a perfect square? Yes. Is one being subtracted from the other? Yes. 3n plus 5, 3n minus 5. Most often I put the positive one first. No rhyme or reason, just kind of the way that I do things. Okay. 25c squared minus 64. Those are both perfect squares. One term is being subtracted from the other term, so we have a 5c minus 8, 5c plus 8. Okay. All right. Last problem in this lesson, problem number 5, factoring out a common factor. So we need to pull out that common factor first. 12x squared, 48. Common factor in those, well, 12, 24, 36, 48. Hey, look, 12 is our common factor. And we're left with x squared minus 4. X squared minus 4. Where have I seen that before? Oh, yeah, it's going to be 12 times the quantity, x plus 2, x minus 2. Okay. Letter B, we've got 12x squared plus 12x plus 3. So if we're looking for common factors in that one, well, 12, 12, that's common, but we only have a 3 there. So we can only bring out that factor of 3. So we have 3 times the quantity, 4x squared plus 4x plus 1. Well, it's not difference of two perfect squares because we have 3 terms there. And, well, let's look and see. Is this a perfect square? Yes. Is 1 a perfect square? Yes. Is the product of this perfect square and this perfect square times 2 4x? Yes, it is, because this is 2x, this is 1. 2x times 1 is 2x, times 2 is 4x. All right, so our factored form is 3 times the quantity, 2x plus 1, times the quantity, 2x plus 1. All right, I want you guys to try letter C and D on your own. Letter C, 12n squared minus 3. If we're looking for common factors in that, 12 and 3 have a common factor of 3. We're left with 4n squared minus 1. Perfect square, difference. 3 times 2n plus 1, 2n minus 1. Okay. Letter D, 18x squared plus 48x plus 32. What is my common factor that I can pull out there? Well, looks like I can pull out a 2 from all of my terms. And I'm left with 9x squared plus 24x plus 16. Okay. Perfect square. So that would be 3x, that would be 4. 3 times 4 is 12, 12x. Doubled it, 24x, yes. 2 times 3x plus 4 times 3x plus 4. Now, let's say you forgot, and you forget these rules. Can you still use either just regular factoring or box method in order to come up with numbers and come up with your factors? Yes, you can. But memorizing these rules and practicing these rules and being able to identify them when you see them is really important in speeding up your solving process. So, for example, when you have a final exam that's only 90 minutes long and it's 50 questions, you've got a way to speed up your solving of those questions. Okay? Make sure you rate your level of understanding 1 to 4. Make sure that you write down any questions you may have after watching this video. And then also make sure you fill out your summary and tell me exactly how you go about solving special cases and what you're looking for to identify them. That's our notes for today. Have a great night.